Hey guys, I'm here to talk about Project 12, Homework 5, alright? And let's get started. So, a couple of things that we gotta know, it's the tangent lines, right? Definition states a tangent line meets at a circle at only one point, right? In which the theorem states that tangent lines are perpendicular to the radii line. Prove this later. So in the bottom of the video, I'll mention a description. Down in the description, I'll mention a video, right? There'll be a video down there in which I hope you guys could watch it. It shows you how to construct a tangent line in the circle. So using a compass and using a pencil, right? Pretty simple. It explains it, but based on this image, right? See here we have our circle. We have our circle, right? Circle P, right? And then we have our line XQ, right? Passes there, and then our line Y passes Q, right? So does both in a class of 1 point, which is named Q, right? And yeah, that's one part of the tangent line. And then for the homework, right? Prove the tangent theorem, right? Let line let ray QXQ and ray YQ be a tangent line at X and Y is a subset of CPR, right? Respectfully, then XQ equals to YQ, all right? And let's look at those hints, all right? So the professor also mentioned some hints in the video, right? If you watch the video thoroughly with or at a double speed, right? Double speed playback, right? You see that she's constructed two triangles, right? There's two triangles she constructed. And then she said find two congruent triangles, right? It makes life kind of simple right here, right? So you see here we have two triangles, right? Triangle XQP, triangle YP, QYP, not bad, QYP, right? And then we have to figure out, well, are these two sides mine? These two sides, XQ and YQ equal to each other, all right? So let's go to the statements and justifications, right? So there's four things that's given to us. Line Q and X is a tangent line to circle P, which is given, and YQ is a tangent line to circle P. So that's also given. Now, so those two things we actually have step 3 and 4 as well. The measure of angle X, QXP equals to 90, which is because of the definition of tangent line, in which in addition to the tangent line, it states that Q and X is perpendicular to P and X. So thus we have this creates a 90-degree angle or a right angle. And then with that, it also similarly goes for step 4, in which is the measurement of angle QYP, which equals to 90. Because step 4 is also definition of tangent line, in which we break it down a little further, QY is perpendicular to PY. Now step 5 steps. PQ equals to PQ. Take a moment and think about it. Why is that? I'm guessing you guys did take a moment. You guys realized it very simply. It's probably based on the reflection theorem. Because both of them lie in the exact same line, so both triangles are probably line the exact same line, right? Line the exact same line. So that's common rule. Oh, so they probably have the equal lengths of that one side, right? Let's go to step 6. XP equals to YP, which equals to R. Take a moment, think about this. Think about that very quickly, very thoroughly, very smartly. You guys take a moment and think about it, or you just waited for a really long time. I applied for that too. Probably got the radii at the circle is equal. Well, if you watch the video, it probably explained to you. And also you can use the exact same idea. Yeah, not the exact same idea, but if you draw a circle, right, with the exact same radii, draw a circle with the radii of, let's say, for example, radii of 2 centimeters, right? It shows it. It shows that, and also based on the video that I mentioned down in the description below, if you guys watch that, please watch that video. It it helps you really draw the tangent line of two tangent lines, and also really helps you when it comes to like understand that two step, understand the first 4 steps, as well as step 6, in which the radii of the circle is equal. So if you draw a ruler and label them, if you measure them, they're both equal to each other. All right. Step 7, triangle QXP is equal to triangle QYP. Take a moment, think about it. All right. So if you assume, all right. So if you probably took your sweet time and think about it, or you just waited for a while, you probably think about it. I thought that could be side angle side because it can't be angle side side because that's illegal to use and that's improper. It can't be side side because we only have 2 sides. We need to make the third side, and which the third side is actually the question asks you to find that side. Can it be angle angle angle? Probably, but it won't make sense. So you can probably work it out. It probably takes a long time. So we just Googled it and said, maybe it could be something else, like the hypotenuse leg theorem. So let me break it down to you what the hypotenuse leg theorem states. Throw it down for once. It states that two right triangles are equal if and only if the hypotenuse and the leg of the right triangle are equal. So we already broke it down a little bit, right? Based on step 5 and 6, right? And also if you just lay one side of the triangles to the side, then you can see, wait, it is a triangle. Because QP is our hypotenuse and XP is one of our sides, right? So it's a right triangle too. So step 7 makes sense. It says, oh yeah, it is the hypotenuse leg theorem, triangle theorem, because well, it's a right angle, it's a right triangle, has a right angle, it has an hypotenuse, and it has a side. So it makes sense, right? Right? Based on that, step 8 states xq equals to yq. Well, plain simple. Based on step 7, right? And also based on the corresponding triangles, right? Because since we have our triangle, right? Since we proved in step 7 that triangle XQP is equal to triangle QYP, right? Since those two triangles are congruent, simply just proven that, wait, since those two triangles are equal, doesn't that mean line XQ has to equal to line YQ because step 7? Well, yeah, that makes sense. Yeah, since you proved those two, since you proved that triangles, since you proved those two triangles are equal, so that means those two sides have to be equal too. So that makes sense. So we finish with since we finished with everything, right? Then we have to double check to be sure. right? So step one and step two make sense because of the given. Step three and four make sense because of the definition of a triangle theorem, which proves that both of those sides, that's proved for step three, line Q and X is perpendicular to line P and X. Yes. And then for step four, definition of change of line. Yep. Line Q and Y is perpendicular to P and Y. Yeah. Step five, PQ to PQ. Yeah. Why? Because of the reflection theorem, of course. Six, XP equals to YP equals R, right? Radii of the circle, which goes to step six. Radii of the circle is equal. Yeah, because we put a, if you watch the video, very much. I'm recommending the video very strongly, right? If we have a circle, and then by any chance measure it, if you draw a circle, measure that circle, please. Measure the circle, and then you see, wait, this is very equal. Because the radii, both of them are the radii. They can put whatever side, right? And put like, let's say, XP, right? The radii of that, well, it is the radii. Distance between them, like, let's say, for example, 6 centimeters, right? So do it again for y, py, right? That means, hey, that would be equal to 6 centimeters, right? Right. And then for step seven, triangle X, I mean QXP, right? As we comparing to triangle QYP, right? Because hypotenuse leg theorem, because well, they're both right triangles, and then we also have right hypotenuse in our leg, so does that really works. So does that the theorem proves it. And then step eight is also based on step seven, which is also based on the corresponding triangles. Since they are corresponding triangles, that means those two sides are equal to each other, thus our theorem is correct. So yeah, that's all it. And if you have any questions, please comment down below, please. I thank you so much for that. Oh, thank you guys so much for that. If you put a comment down and also smash a like on this video, please. And yeah, good luck on you guys' finals too, because our finals are coming up. So good luck on those. And yeah, have a nice evening or night or morning or whatever. If you're on the weekend, also, if you're in the day, good morning, good afternoon, good night, whatever it is, and also have a fun day. All right.